Welcome to Study Time, a televised home learning program produced by Rwanda Education Board.
Hello students, welcome to TV learning programs. I'm Julius, and today I'm going to learn with Senior 4 Economics, our Unit 4, which is Equations and Fractions in Economic Models. Then our lesson today will be about the linear graphs. Then our learning objective, by the end of this lesson, I expect each of you to be knowing how to plot, how to draw a linear graph, and find the slope and generate some linear equations, given points and given points. So before I continue, I have a question here which I want us to first do about the previous lesson that we talked about. Previously, we started, because this is our lesson 2. Our lesson 1, we are talking about a linear equation. We said the linear equation, in economics, we have linear equations that show relationship between some variables. For example, a linear equation that may show a relationship between price and quantity demanded, or a linear equation that may relate a person's income and consumption expenditure. There is a relationship between those variables. For example, you know, when we talk about like the law of demand, when the price of a commodity increases, we expect quantity demanded to reduce, and vice versa, keeping other factors constant. And for example, like when we talk about personal income and consumption expenditure, when your income increases, we expect your consumption also to increase. And when your income lowers, when your income reduces, we expect your consumption expenditure also to reduce. So all those relationships, we can generate linear equations that show the relationship between those variables. So we have this question. An economic researcher did a study about price of a given commodity and its quantity demanded, and formed an economic equation given below. We have quantity demanded equaling 10 minus 0.2 P. P represents price, and this one represents quantity demanded. You know price and quantity demanded are related. So we have question 1, which says how many kilograms of that good would one buy if price was 20 Rwandan francs. So how do you go about this? We talked about this in the previous lesson, in our lesson 1. So your solution, how you would go about this, we have our linear equation here that quantity demanded, QD, is given as 10 minus 0.2 P. Why this one is a negative? It's because here the slope of, if we are to draw the slope of this linear equation, the slope will be negative, showing that there is an inverse relationship between price of the commodity and its quantity demanded. So, how do you go about this? Part A, how many kilograms of that good would one buy if price was 20 kilograms? Meaning that we have our price. They have given us our price as 20 Rwandan francs. This is our price. So we want to know what quantity of that commodity would be purchased at this given price. So from this linear equation, quantity demanded is equal to 10 minus 0.2. So in the position of price, P, which is our price, you substitute there 20. So that is, you multiply 20. So when you multiply 20, we shall have 10 minus, this 0 brings this decimal point here. It takes it away. Then you remain with 2 times 2, which is 4. And when you work out this, 10 minus 4, you will get 6. And we are expressing them in terms of kilograms. So when the price is 20 kilograms, quantity demanded of that commodity will be 6 kilograms. So that's how you work it out, part A. Then part B, they're asking you what price level would make people buy 0 kilograms from the market. So you must rotate on your linear equation. that is showing the relationship between the two variables. So in this case, your quantity demanded, it is equal to 10 minus 0.2 P. But they are saying what price level? So they want P. They want P. And they are saying the price level that would make people buy 0 kilograms. Meaning that here quantity demanded is 0. Quantity demanded is 0. So therefore, if you put here 0, quantity demanded is 0 because they are indicating it here. Will be equal to 10 minus 0.2 P. They want this price. So here you have to, if you bring this side or this the other side, so you can have 0.2 P equaling to 10. So you divide by 0.2. When you get 10 and you divide by 0.2, when you get your calculator, what will you get? What will be this price level? Those who don't have calculators, you can use some simple mathematics. You can multiply here by 10 to remove this decimal point. Then you multiply by 10, both sides. So here you have 100 divided by 2, which gives you 50 Rwandan francs. So this is the price level. At 50 Rwandan francs, people would buy 0 kilograms of that commodity. Quantity demanded would be 0. They have already indicated it. So part C, what would be quantity demanded if the kilograms of that commodity were given for free? You have to note this. If the kilograms of that commodity were given for free, meaning that at 0 price, there's nothing that was charged. So in this case, you restate your linear equation for simplicity. Quantity demanded equaling to 10 minus 0.2 P, which is price. But they are saying here, our P is 0 because we are assuming the kilograms of that commodity were given for free. So here, our quantity demanded would be 10 minus 0.2 times 0. Why am I getting this 0? It's because price charged here, the price of the commodity, the commodity was given at a free cost. No charge was there. So here, the quantity demanded would be 10 because 0.2 times 0 is 0. Any number times 0 is 0. So this is the quantity demanded, 10 kilograms, if there was no any price charged. So that's why this 10, it is like our constant. That would be the quantity consumed when price is 0. When price is 0. So that is how we are supposed to work out that. So I hope it's not very hard. Then let's go to our today's lesson, which is linear graphs. Linear graphs. And I expect you to be able to plot these graphs at the end of this lesson. So what is a graph? What is a linear graph? So in this case, a linear graph is just a graphical representation of a linear equation. Like this linear equation that we have in the previous work we have finished, we can present it on a graph. So a linear equation, a linear graph rather, so a linear graph is a graphical representation of a linear equation. So is a graphical, so you have to note this and make sure you go with me. Graphical representation of a linear equation. So here, we may have different types of these graphs. In economics, we shall have graphs which have positive slopes and those which have negative slopes. So in this case, this linear equation, a linear equation has a general form. So the general form, we have that y should be equal to mx plus c. So this one is a general equation is a general form of a linear equation, y equaling to mx plus c. So you must know, in this case, we are trying to look at the economic variables: price, quantity demanded, income, and the consumption expenditure. So in this case, we can have like, how can we generate the linear graph, like the linear graph for the price of a commodity, the price of a commodity and the quantity demanded, How would this graph be? How can we generate this? And the quantity demanded, So this graph, the graph for and the quantity demanded. So here, how do we plot? We have two axes. We have the x-axis, the y-axis. So here, you have to indicate price. Price is plotted on the y-axis, and we have the x-axis where we plot the quantity demanded. So when it is a normal demand curve, then this is our slope, which is a negative slope. And therefore, if it is a negative slope, how do we generate our equation for this linear graph? Because this is a normal demand curve. You know, from the law of demand, the higher the price, the lower the quantity demanded. As price increases, quantity demanded reduces, and vice versa. Therefore, here, our general equation of this graph would be negative m quantity demanded plus n letter c. So this negative m is the gradient, the slope. Q is quantity demanded, and C, this is a constant. The price of the commodity, the price when quantity demanded is 0. That would be the value of C. So here P, this is the price of the commodity, the price of the good or commodity. Then M, this is the gradient or slope, the slope of the graph. Then Q is, this is quantity demanded. And C, that would be the price when quantity demanded is 0. Price when quantity demanded is 0. When quantity demanded is 0. So when quantity demanded is 0 here, everything here turns into 0. So we shall have our price as that. So when we are going to calculate this, we shall be able to get the value of C. Then you must know that this is a normal demand curve, and this is the general equation of our linear equation of this statement, the linear graph for price of a commodity and quantity demanded. So, for example, in the case of a normal good, what is a normal good? Can you remind me, please? A normal good? Somebody is saying a normal good, that is a good whose consumption increases as income of the consumer increases, meaning that its quantity demanded increases as price increases. A normal good violates the law of demand. You have to know that. So its slope is positive. So for a normal good, its slope is what? Is positive. As price increases, quantity demanded increases. This is for a normal good. So it is a positive slope. I think you know that one. Because realistically, if price increases, we expect quantity demanded to reduce. But for a normal good, it violates that. Price is increasing, people are buying more. So it violates the law of demand. So then, from there, for you to generate a linear equation, you must know how to calculate this slope. We have to calculate this slope. So how do we get the slope? Why we are putting this negative here? This slope is This is a negative slope. So the gradient is negative. But for like a normal good, we don't have this negative. A normal good, we remove this negative because it has a positive slope. For a normal good, the slope is positive. The slope is positive. If this is the price and this is quantity demanded, so we have something of this kind. This is a positive slope. This is a positive slope. So here, if you were to do this, then the general equation would be the gradient plus C. And you must know a negative gradient, a negative slope means that there is an inverse relationship between the two variables. A negative slope means that there is an inverse relationship. So you must know that a negative slope, you have to note this, a negative slope, the slope is the gradient, means that when one variable increases, another one reduces. When one variable, means that when one variable increases, another reduces, and vice versa, another reduces. That's what it means. One is increasing, another one is reducing. So meaning that there is an inverse relationship. So here there is an inverse relationship. There is an inverse relationship. There is an inverse relationship. In this case, there is an inverse relationship. There is an inverse relationship. But now for like a normal good like this one, whose quantity demanded increases as income of a consumer increases, the price is increasing, people are buying more. In this case, there will be a positive slope, like this one, a positive slope. Then from there, how do we calculate the slope? You have to know how to calculate the slope for you to generate the equation. So the slope, this is what you call the gradient. How do you calculate the slope or the gradient? How do you calculate that? If given 2 points on this graph, if we have some points on this graph, a pair of points, how do you get the slope? So we shall use the formula that the gradient, which is our slope, M, we get change in Y. In this case, that will be change in price over change in X. Change in X, that will be change in quantity demanded. So change in Y, you get change in Y over change in X, over change in X. Remember here, on your Y-axis, you have price. So change in Y will be change in price, and on your X-axis, we have quantity demanded. So change in X will be the change in quantity demanded. So here, therefore here, that will be, your gradient will be Y2 minus Y1 over X2 minus X what? X1. So here you will be able to get the gradient. That will be price 2, price 2 minus price 1 over quantity 2 minus quantity 1. So we have this example now, which I want us to work out. When the price of sugar, I want us to read together. When the price of sugar in a local market is 600, a consumer buys 10 kilograms. And when the price is 500, the consumers are willing to buy 15 kilograms. So I want us to go together on this. I want us to go together on this very quickly. Let us try to determine our points. In the first case, when the price was 600, remember the price here, you have to write your coordinates in terms of X and Y. So in the first case, when the price was 600, quantity demanded was 10. So when the price was 600, quantity demanded was 10. So we have 10 kilograms. 10 kilograms were demanded when price was at this. Then again, you must know when the price was this, quantity demanded was 15. Begin with x coordinate, and remember x coordinate, we have quantity. So quantity, this will be 15. 15 kilograms were demanded at 500 Rwandan francs. Now, in this case, you have to generate the slope. Let us first look at the slope. Our part A, they are saying represent the consumer's demand curve on a graph. So how do you plot this? So you have to plot. How do you plot this? This is, you have to draw your graph. So let's try to sketch. Remember here we have price on y-axis, and we have quantity demanded on the x-axis. This is 0. So our quantities, we have 10 or 15, so we can have here 10, we can have 10, we can have 15, we can have 20, we can have 30 if you want. Then here the prices, we have 500. You can get a suitable scale, 100, 200, 300, 400, then 500, then 600. So you plot. At first, when the price was 600, then quantity demanded was 10. So we are trying to sketch our demand curve. Then when price was 500, quantity demanded were 15. So you have to try to sketch. Then you draw your curve. So this is our demand curve. Represent consumer's demand curve on the graph. So this is our graph, of which we have to look for this slope. What is the slope? The slope here is a negative. You can see it is sloping from left to right. That is a normal demand curve. Because as price was increasing, quantity demanded was reducing. At a lower price, the consumer bought more. So this is a normal demand curve. So how do you get the slope now? How do you get the slope? So you have to calculate the slope, which will be change in y over change in x. You know that one? So, but it is y2 minus y1 over x2 minus x1. We have our coordinates here. So this is x1, y1, x2, y2. So you substitute now. Our y2, we have 600 minus y1, which is, no, our y2, we have 500. We have 500 minus our y1, which is 600, over x2, which is 15, minus x1, which is 10. So in this case, you will get the negative 100 here, divided by 5. And here, this gives you negative 20. This gives you negative what? Negative 20. So the slope, our slope, which is m, the gradient, is a negative. You can see this is a negative slope. So you must verify it from this. So this is a negative slope. Let us now form a linear equation. After getting this, we can form the linear equation. You have to look at the general form. You can state this, our linear equation, our general equation, P equaling to negative, this one plus C. Or even you may ignore this, that in the substitution you have to bring it. So P is equal to our M, which is our gradient, our slope, is negative 20. Okay? Negative 20 Q plus C. But we can look for this C. How can we look for it? You can get any pair here. Any pair, you can use either this or this. You choose one. For example, if we choose this, when price was 10, we have our negative 20 here. Quantity demanded. No, when price was 600, our price is 600. Quantity demanded was 10. then you add this C. So in this case, 600 is equal to, when you get negative 20 times 10, you get negative 200 plus C. So our C here, when you correct like terms, it will be 600 plus 20. So our plus 200, so our C is 800. So our general equation, they are saying form a linear equation showing the relationship. What will be our linear equation? Our linear equation will be P equaling to M. And what is our M? What is our M? Our M is negative 20. Q, quantity demanded, plus C, of which C is 800. Of which C is 800. So this is our linear equation showing the relationship between price of sugar and quantity demanded. P equaling to negative 20Q plus 800. Plus 800. Meaning that here, when quantity demanded is 0, then the price will be 800. Will be 800. I think you are following that one. I think you are following that one. Then, before I finish up, I have an activity for you. In a local market, when the price of beef is this, an average consumer buys 3 kilograms. And when the price is this, he buys only 2 kilograms. I want you to represent on a graph like this. Then from there, you will estimate the number of kilograms he would buy if price was this. For example here, if price was 300, what would be the quantity? You can even estimate from the graph. If price was 300, quantity demanded here, you can see it is 20. You can estimate that. If price was 200, quantity demanded, you can check. It is 30. So likewise, if you come to this, you will use your graph, then you estimate the quantity demanded of the commodity given the price 3,000. Then after you form a linear equation for this demand curve. Remember, to form a linear equation, first calculate the slope, which will be changing in price over changing quantity demanded. Then from there, you can even, for your reference, you can look at Economics for Rwandan Schools, Book 4. You can look at that, Economics for Rwandan Schools, Book 4. For Rwandan Schools, Book 4. So you can check from there, then you read more information. Remember, please, to form a linear equation for this demand curve, calculate the slope, and this is the way which will be changing price over changing quantity demanded. Price is plotted on y-axis, then quantity demanded on x-axis. And I expect you to come up with such a linear equation, price being expressed in that. Hope you have followed me. Thank you for listening. We meet next time in the next lesson. Bye-bye.